Metamorphic rocks, you're going to want again to be on page 7 of your reference tables, but for metamorphic rocks, we're going to be on the bottom of the page for the scheme for metamorphic rock identification chart. So make sure you have that out and open while we're going over this and you're going through your notes. Okay, so how are metamorphic rocks formed? Well, when rocks that already exist, so a rock that already is a rock, okay, and it's changed by heat and pressure into some kind of new rock. So what happens is you have like your limestone. It undergoes a lot of heat and pressure because there's so much pressure on it, because there's so many layers of rocks on top of it, and it's actually all that pressure is causing there to be some heat. It changes the crystal structure inside of the rock, which eventually this limestone can be smushed into marble. Marble used to be used and still is used for things like statues or building columns or tiles or different things like that. Marble is a really pretty rock. Well, marble used to be limestone before it was made into marble. So marble's kind of old. You gotta think how long that limestone probably took. It took thousands of years for the limestone to be made. Well, the marble took even longer for it to undergo heat and pressure. That marble's really old, okay? And I did not want to click that button. Oh my goodness. There. So, if you look on your reference table, you'll see the scheme for metamorphic rock identification. So you'll see here there's this foliated section. We'll talk about that in a little bit. You have your grain size, what composition, so what minerals are used inside of it, the type of metamorphism, so if it was regional, which means that it underwent heat and pressure. There's different comments that we'll go through, and then you have your different types of rocks. And then again, we have our map symbols, which will come up later on in different units that we're going to use. And then you have non-foliated, which follows a similar structure. There's just a difference between foliated and non-foliated, and I'll talk about that. So what happens with these metamorphic rocks is because there's so much heat and pressure and so much going on with them, there's a recrystallization inside. The rock crystals inside of it are actually going to reform and realign, and it's going to make it into a different type of rock. So what happens is the process in which rocks undergo the change without truly melting. It doesn't actually melt into a liquid. It does soften it, but it's just enough that the crystals can realign inside of it, but not completely melt. Because if it completely melted and then re-solidified, that would be an igneous rock, or metamorphic rocks don't completely melt. So what happens with a piece of sandstone inside of it, you can see the crystal structure is kind of haywire. It's all over the place. Where it undergoes a lot of heat and pressure, and that heat and pressure is going to have those crystals inside of it realign in a different direction. So it's not the same rock, but it was made from sandstone. So sandstone actually can metamorphose into quartzite. And because a lot of times those the recrystallization can actually make the rock harder and more dense because it caused that recrystallization structure. Sometimes it actually it smushed more mass into the same space. And a lot of times quartzite is way more dense than sandstone because of that heat and pressure and recrystallization. So there's a couple different types of metamorphism. Regional metamorphism is when a really large area undergoes a lot of heat and pressure. So sometimes when there's mountain building where two continents or two plates are smushing together, that's going to cause a lot of regional metamorphism and a lot of heat and pressure, because there's actually friction that's being created when there's lots of pressure being pushed down. So that heat piece is there too. Then you have contact metamorphism. What contact metamorphism is where you have your rock already there, and there's magma that comes up through. All the area surrounding where the magma was, where that original rock was and where the magma touches, is going to cause it to change. It's not going to melt it completely, but it will heat it up enough that it's going to cause a recrystallization happening there. And this is where you're going to have all around here, you're going to have a metamorphic rock. So this rock right here probably is sedimentary of some sort. You have your igneous rock coming up and heating everything up. And then you're eventually going to have a metamorphic rock that's going to be all around the outside there. You see that there's blue lines? Those blue lines are representing hash marks. that's actually contact metamorphism happening there. So that's where your metamorphic rock is going to be formed. So you've got regional, which is heat and pressure, and you've got contact, which is where it was heated up from magma surrounding it. So now there's different metamorphism characteristics. You have foliation. All foliation means is that there's going to be layers. There's going to be smushed in layers. So they have formed by the recrystallization under pressures associated with regional metamorphism. The more pressure and the more it pushes down on it, the more foliation you're actually going to see. So it causes layers or banding. So with your fine grain, which is slate, there's very thin foliation. Slate actually came from shale. Shale, it was metamorphosed and underwent a lot of heat and pressure from regional metamorphism, and it turns into slate. Then you have medium grained, which then turns into schist, where the crystals are actually starting to become visible now because those minerals pushed and reformed and kind of recrystallized together. It's pretty cool. And then you have your coarse grained, which is nice. And it's the separation of minerals, and there is significant banding that you can see. So here you have your slate, and then you have your schist. Now this is phyllite. So schist, let Miss Baker start over. I've been talking a lot. So you have slate, then you have phyllite, then you have your schist, which is actually has really pretty flaky little crystals. If you have schist in the sun, it shines and it's really pretty. And then you have gneiss. Okay, there's banding in this one, clear banding that you'll be able to see in gneiss. Okay, now very rarely do you ever get a fossil in a metamorphic rock, and the only way you can see it, you'll actually notice that it is very distorted. It can be stretched, it's very flat, and a lot of times you just can't recognize it because it's been just so distorted. Also with some metamorphic rocks, you can have pebbles that have been like flattened and stretched. Those that'll come with like metaconglomerate, because you know conglomerate is made up of all different size particles, large and small, and they have been cemented together. Well, if you take that and you compress it and have lots of heat and pressure, those like larger pieces in your conglomerate are actually going to be flattened out, and you can see that sometimes. So that would be metaconglomerate. Sometimes with metamorphic rocks, you're going to have folding and twisting of rock layers. They're not flat, so that's why with gneiss you can see the different banding layers because there's so much heat and pressure pushing them together. So the relationship between banding and the degree of metamorphism, the more temperature and the more pressure, the more banding and the thicker the banding is you're going to see. So thick banding indicates a high degree of metamorphism. Crap ton of pressure, crap ton of heat. And it's going to let those crystals kind of realign with each other, and you'll create those thick bands. Where can you find metamorphic rocks? Actually, you can find them in the Adirondacks, but it's wherever there's lots of heat and pressure. Why the Adirondacks? Because there was a lot of stuff pushing together when it made those mountains, so that's why there's metamorphic rocks there. Magma or lava can do it as well, because you have the contact metamorphism where it's touching around the outside through those already formed rocks. Parent rock is the original rock before it was metamorphosed. And so you're going to make sure that you go through your charts. We're not going to do the warm-up, and this actually brings you through the rock cycle. So if we go back to the page 7 of your reference tables, oops, just went back. So you'll see, here's your foliated. So this is where that there's crystal structure that it's going to be aligned, okay? Excuse me, you have mineral alignment, and then you have banding. So you have fine-grained, fine to medium, medium to coarse. You're actually going to notice too that mica can be in all three of them. Mica kind of makes it shiny, but pyroxene doesn't show up until there's lots of metamorphism happening, okay? Then you have the type of metamorphism. So what this means is at the top, less metamorphism. The more it pushes down on this chart, the more metamorphism that happened. So slate, not a lot of alignment that you can really see. There's some, but the farther that you go down with these, especially when you get to gneiss, you can see thick banding. So less metamorphism, all the way down to crap ton of metamorphism. Then you can see your comments that slate is a low-grade metamorphism of shale. Shale is your sedimentary rock that's up in your chart above, but then shale undergoes some heat and pressure. It can turn it into slate. Slate can then metamorphose into phyllite. Phyllite then metamorphoses into schist. Schist metamorphoses into gneiss. Okay, and then you have your non-foliated ones. So these guys are not going to show mineral alignment in them. You can look at their grain size. You can look at the composition. Like anthracite coal was made from bituminous coal, and there's carbon in it, and it tells you the different types of metamorphism. So some of these are regional, some of them are contact. Hornfills are always contact. And then you have your comments here. Some of them tell you what the parent rock is, like quartzite, the parent rock was sandstone. Marble, the parent rock was either limestone or dolostone. Metaconglomerate, the parent rock is conglomerate. So this is the metamorphic rock chart that you do need to know and you do need to cover.